It's running, John.
Okay, all right. Good morning, ladies and gentlemen, and thanks for making time this morning to attend our presentation. And good to see a couple or some new faces and other faces that we haven't seen for a while. Just by way of introduction, John Malan lives in Kleinmond, so he's another of our Overberg Geoscientists group. He's a retired petroleum geologist, remains active as a sedimentologist and geoscientist, and he's a great resource and a sort of person that we should be listening to a bit more. Jean's last employment was as a senior geoscientist in the GTech group in Leeds, in the UK, with Africa and the conjugate South America area, his area of focus and speciality, and that was from an oil and gas point of view. Earlier, he has worked as an explorer, sedimentologist, chief geologist, new ventures business developer, and manager for New African Global Energy, New Age, as they're known, out of London, New Age in Johannesburg, Petro South Africa, Sasol Petroleum International, Namcor in Windhoek, and previously Suco in Cape Town, where he started his career as a petroleum geologist in the 1980s. John was a field geologist for the Council for Geoscience beforehand, where he focused on the geology of the Southern Cape Province, the subject of numerous maps and notable publications. He studied at the University of Stellenbosch, where he did a BSc Honours and MBA, and did an MSc at the University of Cape Town on the sedimentology and stratigraphy of the Bredarsdorp group, Southern Cape Province, and that's what he's going to talk to about today. Thanks, Sean. Over to you.
Thank you so much, John, and hi to everyone, small and big, young and old. Right, as John said, the whole credit of what I'm going to share with you on the next 40-odd slide, the bulk of it goes to the Council of Geosciences. On those years, the Belleville office of the Geological Survey. So let's get going. So what I'm going to take you through is a brief introduction to South Africa's coastal fringe, Cenozoic cover sediments, the Bredarsdorp group, and up on the top side is the lower Bredarsdorp, that's the Hoopvlei and Wanku. On the lower corner is the later or upper Bredarsdorp, which is the Kleinbrock and Warneskrans, that's Pleistocene. And then blowing all over that is the Holocene recent Strandveld. We'll touch sea level highs and stands, and then so that's plain surfaces and some Holocene beaches that occurs within the coastal fringe of the Overberg. And then lastly, if time allows us, is just to taste your buds for yourself with a couple of potential field trips in the new year. That would be all under the cover of the Overberg Geoscience group. Right. South African coastal Cenozoic deposits. I give credit to Robertson and his whole team of a fabulous publication that covers all of the coastal sediments. And in this case, it's the West Coast. As we swing around Langebaan, Saldanha to Cape Town is the Sandveld unit. And okay, then the South Coast, that's pretty much the Bredarsdorp group, between just the Stanford Hermanus all the way to Plet. And then we've got the Eastern Cape, and that's the Algoa. And then up north is the Zululand. So just to zoom into the Bredarsdorp sediments, as I said, from Hermanus in the west to Plettenberg Bay in the east. Without going into the details of the tables, that's the different groups. It's a Sandveld, Bredarsdorp, Algoa, and Maputo. But starting from the base, we are going to focus on the Hoopvlei and Wanku. It's these two, and you can see ages for them, Pliocene. And then the upper units, the Kleinbrock, Warneskrans, and that's Pleistocene. And there's the Strandveld again, the Holocene. And what is so good about this table, it puts the Bredarsdorp in perspective of the whole coastal fringe packages. Right, just got to step one back again, and that is geology and the stratigraphy of the Southern Cape, and that's pretty much the Overberg. So we've got basement, Malmesbury and Cape Granite, and then the bulk of the outcrops is Table Mountain Group and Bokkerveld. So that's Ordovician, Silurian and Devonian, and then a large jump and a gap before we pick up a couple of Jurassic Cretaceous Utinate outcrops, and then finally that's the cover, the Bredarsdorp. On top of that, you'll see me coming back to Table Mountain, Bokkerveld, and the Utinate sediments as basement to the Bredarsdorp. Right. So more detail on the Bredarsdorp and just a summary strat column. And in this case, you can see the basal De Hoopvlei formation formed by calc arenites and with low angle crossbeds, plenty of shoals and conglomerates, but right at the base, a conglomerate unit, a calcirudite with broken shells, the cookinites. We'll go into detail into each of these units. So on average, about 17 meters. Overlying that in the Pleistocene is the Vanku, that's the Aeolianites, calc arenites. And then we've got the Stein Gap, the jump to the Kleinbrak and Varneskrans, again the same, a marine shelly package, shallow marine, and then Aeolianites, and then the young Strandveld. Right, to the sea level curve, and that's how I had it many years ago, to tie in the De Hoopvlei formation and the Kleinbrak formation, and again linking it, those two back to high stands. In this case, an upper Pleistocene high stand and regression phase, where the De Hoopvlei formation was left behind, deposited, and then later on, I mean, the Bredarsdorp plain, coastal plain, has been again encroached and flooded by high-level stands, and then right at the Pleistocene, we've got again the Kleinbrak and its subsequent unit, the Varneskrans. Looking at the map, and big credit to the Council of Geoscientists for the southern part of the Worcester sheet and most of the Riversdale sheet. I was pretty much involved with the mapping here and most of this section of the map. So those are the 1.25 million sheets. I'm zooming yourselves into an area of interest that is around the Hoopvlei. So Bredarsdorp here, and that's east of Bredarsdorp, and not only the stratotype of the De Hoopvlei, but a very interesting outcrop. So jumping back to the maps again, and the nomenclature used by the council is T in the case here for tertiary, and D for the Hoopvlei, tertiary Vanku, Q quaternary Kleinbrak, and then QW Varneskrans, and then the Strandveld formation. Just zooming in, and this map will come back and forth to us. That is the De Hoop Resort with the De Hoopvlei, and a river cut made by the Sout River. Right, I'm taking you straight into the Sout River just as it was. It made its cut and it breached through the Pleistocene Bredarsdorp, and in this case, weathering or cutting into the cirrus or the Bokkerveld sediments, and we can also, on the map here, red indicates the Jurassic or the Enon. So the same happens. I'll zoom into another map, but what is clearly, we're looking from the Rhônes towards the sea, so that's north-south, and we see the sloping multi-phase wave-cut surface and unconformity, and it's on this surface that the light Pleistocene regression low stand left behind the De Hoopvlei units. So on the right is just zooming into the De Hoopvlei package. Stepping one out of a Sout river is again regionally, and I've got the location of quite a few measured profiles, part of my work for the council and my thesis. And the De Hoopvlei varies. The thickness of the De Hoopvlei varies depending on the underlying bedrock. In the case when it's Table Mountain, which is in the Potberg Cape Infanta area, it's and around Gouritz, Vleesbaai, it reaches a thickness of barely 2 meters. When it's softer Bokkeveld, like an example from Stilbaai, just before you enter Stilbaai east-west at the bridge, there's a lovely exposure of the Hoopvlei on top of Bokkeveld. And then later on, I'll show you the Hoopvlei and the Bredarsdorp on the softer Enon formation. So then for those cases, the thickness varies between 4 meters and 17 meters. So we're talking about the Hoopvlei, which I've indicated here in the bluish colors, and then the upper section in the case of a profile at Stilbaai, it's a calcarenite, and then overlying that with the aeolianites. Going to the holostratotype, so that is the true type locality of the Hoopvlei formation. And I was very fortunate when I was there in, let me just think, in the late 80s, the level of the vlei, you can see I've put it in where it is today. That's where Mike and myself were a couple of months ago. And the water stood pretty much at that level. So on the right is my measured section, and we start with it's limestone calcarenite with shelly material. But what is quite clear is these basal units that as well developed bioturbated packages, and as much as 2 meters in this case, present day basically all covered by water. Plenty of burrows and borings and tubes, Ophiomorpha, sand prawns, crustaceans. You find up to more or less 8 meters. It's as I said, that's the well bioturbated, and then as you move into a different setting and environment, we pick up the others. Paleontology, and you can see that's Echinodiscus, Glycomeris, Travella, Schistodesmia, species. I'll flash that on a little later. There's a couple of extinct. Just to get us starting, as we pretty much in a shallow marine environment, shore face environment in this case. Zooming into the sedimentary structures. So again, we're looking at the medium coarse grains, calcarenite, scattered pebbles and cobbles. You can see good examples of the different size floating pebbles and within the calcarenite. And then in the middle, okay, again, the basal section here refers to the lower unit of the De Hoopvlei. And these slabs, we'll zoom into them later, is well bored and drilled by living organisms then. So horizontal bedded and low angle cross bedded units with well-defined phases between them, trough cross beds, etc. Right, back to cut off the Salt River. This is a snap taken off my original field maps, 1 in 50,000, and they spliced together. But what I point out to you is that the Salt River cut presents us with, in the upper case, that is north to south view, and that's Aasveld Krans. And the Hoopvlei is that snake of green The overlying Vanku T is the lighter, but what I need to point out is the lighter green, that's basement. DV, in this case, that's the Devonian. And in the case of the orange color, that's KE, that's Cretaceous Enon. So again, looking at the two photos, there's the Bokkerveld forming basement to the Bredarsdorp succession. And this is a view straight into the dunes looking west. If we swing around, and that's virtually, you're at this outcrop, and you just got to turn yourself in the direction facing the current shoreline. So you look south, and that's what you didn't then pick up is the Enon, or the Uitenhage forming basement with the Whip and Vanku above it. So that's that yellow arrow in that sense. Do note between the Devonian and Jurassic, there is an indication of a fault, and that's a fault line that extends well into the offshore, into the western Bredarsdorp offshore basin. Just a quick note on the paratypes of the De Wipflei and Vanku. And again, the lower unit, that is the De Wipflei, and the overlying is the Vanku. And again, in this case, there's the measured section, and we're zooming into this part, of which I'll show you a little bit more coming up. So again, on Enon, and it's in the region of about 9 meters thickness. You can see the calcarenite, I tend to color that in yellow versus more the calcareous material lower down. And right, zooming into, let me just put you in the picture. So we're zooming into this section now and getting a more close-up of the De Wipflei. So that's a scale of about 10 meters. At the base, eroded or deposited into eroded hollows into the Enon is this basal boulder unit, pebble unit, and in places growing and oyster or ostrea cells are broken up. Just a unit above that, we pick up cross-bedded units with reactivation surfaces. You can see quite a few of that with cross-bedding and a bit of trough cross-beds in there. Sharp contacts at places, and planar and herringbone units. Right, quite exciting to look at the ichnofacies. So that is where living organisms live. I've got Ophiomorphonodosa, that's the sand prawn burrows. This is a view from the top, and there you can see them drilling down. There's another one, and a lovely burrow that has got a centimeter thick lining of agglutinated pelletoidal sediments, forming a strong protection around it. In section, you can see those burrows going down, and that's 30 centimeters and even more. We also pick up these Scolithos in plan. Right. Just a word on the paleontology, and let's not get the photo or the picture in first, but we've identified 55 macrofossils, of which 8 of them, and these are the few crosses on my table, is extinct. One of them being of an echinoid discus, and this is taken from the De Wip section at the Wipflei camp. There's 1, 2, 3 of these lying still in living position on a bedding surface, 3 of them, and that's the modern one. I did show you the oyster bank that's formed, and okay, for that you require a bit of a sheltered environment. On the macrofossil side, so that was Ian McMillan and his team in the Sukkot days, did correlate a widespread of the benthic forms in the De Wip ties with the offshore marine settings as well that they picked up in Wales. A couple of Odentaspis, Aquatisma, that's a shark teeth, but just here and there. Paleocurrents, once I had time to look in more depth into the sedimentary structures, measuring dips and strikes on these units. You can see a spread of measurements, but the summary clearly shows a northwest southeast direction and a north-south and more an east-west direction, whereas this I equate to the onshore-offshore movement of sediment, and then the influence of a longshore direction and longshore currents and drifts. Right, a snap summary again on the environment that we're focusing on is we're in the shore phase foreshore, but stepping out onto land proper in the backshore with the dunes of the Wanku behind it. Once getting into the deeper water, and that is just below storm wave base, that is where we pick up the biogenic structures and the burrows, also in sheltered positions in the shore face. We see that on modern beaches when the tide pulls out. We can see where the prawns and the worms and those things were doing there. Yes, away. I've just got another snap. Apology for the black and white. The water level at this outcrop is pretty much covering the bulk of what you see on the black and white. So we're looking at unit or facies 8, facies H, sorry. So that's in the transitional zone, and it's bioturbated, well bioturbated, fine to medium sands. We move up into the upper shore face area where our sedimentary structures come in. There's a lovely incision of a channelized unit filled with pebbles and gravels, and then finally we are reaching the upper sections. That G should have been an F anyway. Right, to the Aeolian unit, that's the Wanku, which also forms extensive coastal outcrops, and I've got topographic highs indicated on this regional map. The Wanku is characterized by large-scale Aeolian crossbedding. It conformably overlies the whipflay. The type area I've picked was west of Stilbaai in the Wanku Valley, and thickness of this unit varies between 80 and 130. Max of 180, average of 130. And it forms these ridges along the south coast. Right, the stratotype, so it's pretty much, that's the contact with the De Wip, and that's the Wanku. So there's the De Wip flay, and that's the Wanku unit. And in this case, a measured section of give or take 120 meters, formed by the softer calc arenites at the base, and then the calcareous sandstones, and there's terrestrial shells in them, but it's massive and large-scale Aeolian crossbeds characterize the Wanku. So this deposit accumulated as backshore dunes, and during the late Pleistocene as during the low stand regression. In cuttings like the Salt River cutting, we see these caves and solution cuttings and hollows, and that's a zoom into a closer section. So the large-scale Aeolian crossbeds within this paleodune cordons, and interesting, a couple of convex upwards facets could indicate presence of parabolic dunes. Terrestrial gastropods in hollows, I found a few of them just washed in places close to the contact. And so there's the caves and the hollows, and everything. The section is backed by a hard calcrete at the top. We're just turning again, looking west, and that is Aasveld Krans, and you again see the caves. And when we zoom into these caves, these lovely weathered honeycomb weathering, and between the Rooikrans and Aasveld Krans, up into the little side valleys, we can also see caves that's been weathered into the Vanku. Right. We
John, sorry, just John, sorry to butt in. Why don't you give us some absolute numbers? You know, you and I are familiar with the Pleistocene, but
okay,
you know, if you know what I'm talking about, and we'll edit out this little conversation.
no problem. Right, we are when we look at the lower, or in this case, the De Hoopvlei and Vanku, with the Pleistocene, I'm at the upper Pleistocene. I'm in the order of 3 million and younger, maybe even younger than that, 3 to 2 million years of age, 1.8 max. And then when we jump to the next unit, which is the late Pleistocene, we are in the proper younger events, and there we look at 1 million years and younger. Back to later on, our sea level curve should pop up again. We only have these coastal units preserved. The sea has been up and down many times in the late tertiary. So again, we're talking about in the late 30 million years and younger. At one stage, it went as high as the foothills of the Langeberg Mountains. The Bredarsdorp was deposited in that time frame of, as I previously mentioned, 2 million, 1.8 million for the lower unit. And now we're looking at the upper unit. That's in the Pleistocene, upper Pleistocene. And in the case of the Kleinbroek, that's a sea level curve. That's time, and that's present day sea, that's above and that's below. And we can see during the last interglacial, so the ice caps really sucked up the ocean for us, and then it was just pulling water and the seas down to about 120 meters sub sea level off the edge of the Gullis Bank. And during this phase, that last that glacial period, we had the formation of the Kleinbroek. This is its type locality. A fair bit of gravels at the base, sandy units between. You can again see the typical marine sedimentary features. And in this case, what helped us a lot, the survey drilled a borehole close to Hartenbos, and that penetrated right down into the Uitenhage sediment. So we're looking at its overlying sediments in the order of 180 to 140 million year age, would be the lower Uitenhage or the Enon. All right, so that's a stratotype, and the Kleinbroek varies anything between 0.5 meter to 8.5, 9 meters, and it's average about 3, and it is deposited below the current plus 18 meter contour line. So you can really get that impression. It just hugs the present day coastline. What helped me a lot was the Swartkops fauna assemblages, which we use as criteria for mapping. So again, we're looking at a shallow marine beach and in places estuarine lagoonal unit. And right, again, without going into details, plus 130 species, and again, the extinct late Pleistocene species to the south coast is on these to the left of the species name. And that's ascribed to that these gastropods and bivalves were living in the late Pleistocene. So that's 120, 150,000 years ago in warmer waters. So the Mozambique current at that stage brought us like, Durban type of waters along our south coast. That would have made good fun for swimming today, I would say. So another controlling feature for me was the color of the shells, or whether it's complete or broken up shells, but original shell color was preserved in the kleinbrak. So that's the pinks and the purples and the light blues. Whereas if you look at the whipfly, it's all white. There's the last statement, microfossils, again, benthic forms extensively cover most of the Achilles bank as well. Going into some of the kleinbrak outcrops, a fascinating area, there's Gans Bay. It's this coastal stretch, which I hope to share with the OG guys early next year, between Quint Point and Buffeljags, at 2.5 k's, we get to view these sea cliffs, coastal outcrops of 20 meters. There's the basal kleinbrak, so that's the marine estuarine unit covered by the Aeolian Varneskrans and a calcrete cap. So zooming into the lower unit, that's a kleinbrak. We've got a basal unit right at the base. It's normally covered by high tide. Then it's indicative, this specific unit, of wave action. It deposited well eroded, rounded, elongated material, cobbles, pebbles from the adjacent peninsula headlines. It's then overlain by a low angle cross-bedded, bioturbated calcarenite, and that's, I said, from a more sheltered back barrier laguna location. Within that, there's dark brown organic units. And in this case, Mike is standing next to a few of them. And we looked at the dating of these units, and they've got pollen belonging to the modern fynbos species within these organic or peat-like units. Also, Mike's hammer is there on oxidized iron-stained horizons. That's also an indication of a bit of terrestrial input. So all of this covered by the Varneskrans. So that's, again, the section. In brown is the bioturbated units, black is the PT-Moor unit, yellow is our calcarenites, whether it's at the top section, that's the Varneskrans unit. Right, zooming into the bioturbated section at the base, Ophiomorpha burrows from a sheltered environment. So Mike is standing at the unit, and that's a zoom into all the burrowings. Just above Mike's head, and that's pretty much what I've encircled there, is on the contact between the kleinbrak and the Varneskrans, we pick up these features. So the Varneskrans, the Aeolian unit, forms that cliff of 7-8 meters. So what could we be looking at here? we call them organ pipes, and so it's these directional or horizontal, similar orientated pipe, spike-like features, and it occurs at several places along the contact between the more the clayey upper kleinbrak and the sandy Varneskrans. So clearly secondary calcification along linear layer parallel porous zones on the contact, and could have been there due to water action, sheet-like water, more carbonaceous rich groundwaters flowing along porous pathways and then cementing grains. Could even be wind action with riffled surfaces, wind-blown surfaces on that contact, slightly more wet, and wind being blown by the stormy westerlies or southerlies, just huck and adhere itself to that surface. Or, so yeah, like it said, continual grain orientation and later preferred cementing. Originally, I also had the thought, could these be calcified reeds and reed stems just in pockets? Right. A couple of other locations of the Kleinbrak, and that's where we've been a month or so ago, and that is at Klipgat Cave, Middle Stone, late Stone Age people, but credit to the Bredarsdorp forming the roof to the shelter. So there's the Kleinbrak, and there's my message section again, a basal boulder unit, and then going into the calc arenite, and then overlying that is the Varneskrans, very sharp contact with steep dipping Silurian formations of the Table Mountain group. Walking further along the coast, that's just around the corner towards the Walker Bay side. However, once you start walking along the coast and you follow Mike's Kelder Gansbaai Dew Trail along the coastal stretch, at quite a few places we see the Kleinbrak, or that is the the beach deposits of 120,000 years or so ago, that's been left up at a higher level. In this case, should be in order about a +3 to +5, but its furthest inland elevation is about 18 meters. A stunning outcrop is on the southern bank of the Klein River Lagoon. As you drive towards Mosaic and Wortelgat, you see Kleinbrak exposures with crossbedding and trough crossbeds, and there you get an impression of the coarse nature of these calc arenites. A quick one around Honest and Varneskrans at the coastal, once exposed during low tide, is pebble units and a pebble layer that and overlying that more a massive unit at places horizontal bedded, and the boldest pebbles can be off the Table Mountain quartzites or even reworked. There's a large, about nearly a meter, half a meter to a meter boulder. It should be of the older Bredarsdorp. Right. So the Varneskrans sediments covered the basal Kleinbrak. Two fabulous outcrops again on the Kleinbrak at Dana Bay. So that's just west of Mossel Bay. When you walk along the beach, you pick up these well-cemented Aeolian crossbed unit, and there's a contact, and on top of that, a calcirudite, and then some low angle crossbeds over that. I saw that as this could be preserved Vanku. So again, that's the give or take 2 million, and this is the overlying Kleinbrak. That's the calcirudite low angle. Just between the mouth of the Duivenhoeks, so that's between let me just think again. Okay, Stilbaai, west of Stilbaai, at the Duivenhoeks Rivier, there's coastal outcrops on a farm with the name Steenkoolfontein. When you go down there, and during my mapping, that's what I picked up, is these basal peak unit. It's 1.5 meters thick, with plant material, wood material, lots of pollen. The pollen similar to the fynbos, and then it's located on Bokkenveld. We're zooming through up now into the Aeolians. That's the Varneskrans, and again there's the lower Kleinbrak that I pointed out earlier, and that's capped by the Varneskrans, and this is the type area at Arniston, large-scale Aeolian crossbeds. There's often paleosoils. We'll come back to that just now. So it's fine broken-up shell material that's been preserved in mega dune features. Maximum thickness 200 meters in the wilderness Knysna. There's examples from the Walker Bay coastline, and this is again around Arniston, Varneskrans. Just again for my thesis, I measured paleo directions, wind directions, and there you can see, no surprise, pretty much the same as modern days. So that is 180 planes at the measured bedding planes at 4 localities. What excites me is to find actually evidence of living organisms that either, in this case, beetles or worms that's moved up a bedding surface, and in this case, a nicely meniscated backfill trace suggested that the creator moved down the lee side of the dune, and this was close to Copialean. Within the Varneskrans, plenty of shell like Acanthina, etc. But let's just look at some of these burrows and borings. So coming back to our field trip with the Oxford a couple of weeks ago, and we're at the exposures of the Varneskrans along Walker Bay, and what caught my eye and again Haley's eye is this slab, and you can see the potted surface. However, if you walk around it or you look at this side, that is what you see. And we ascribe this to likely dune moles that's come down and had a bit of a quiet time here, and then again going up and down. And this comes from the Arniston outcrops. Stepping back to work that Haley and her team did east of Stilbaai. So zooming into those Pleistocene dune cordons and looking at that low angle laminated facies, which they refer to as, and this is this unit, as the elephant footprint track or trackway. And there you are. That's the larger or the adult, and there's a younger juvenile crossing that. We spotted, well, maybe something alike, and that's possible Cape Buffalo footprints, and that's on a slab just before you enter Klipgat at the Keller's Cave entrance. Right. What we're now coming to the surfaces of either the Vanku or the Varneskrans, and we see these calcrete cap rocks and fynbos, so finds itself and it roots itself in little crevices and cracks and infiltrating rainwater, as well as the acidity brings about these lovely weathered features at the top. But then also, when you look at some horizontal surfaces, you see these irregular, uneven root calcification casts. What's it? Rhizolaths. And these on top of Hoëvalle and at Varneskrans. Right. Close to wrapping up here. So we're looking at the Holocene, so that's pretty much recent day, and that is the Strandveld formation, which is the coastal dunes, and there is the Walker Bay area. And as I've written there, the type locality is once you walk at Bantam's Klip and you walk from the modern beach into these unconsolidated sands, but they grade into stabilized, partly vegetated dunes of the Holocene, Strandveld. And that's the dune field at the mouth of the De Hoop Vlei with Copialean. And I've just marked these dunes hugging the present-day coastline. The summary again, what were we dealing with, what were we looking at during this talk, is that's what you've seen earlier, but we moved from the transitional offshore zone with all its bioturbated borings. We move up the slope into the transition shore face. We're in here with cross bedding and troughs and herringbone structures into the foreshore, where we pick up a lot of pebble and boulder washes. And once we breach the barrier of the backshore into a lagoonal setting, a back barrier setting, and then the coastal dunes, either at the back or just the lower dunes here. So wave cut platforms all along our coastline, and just snapping through a couple of them here. I'm looking at my time. That's the Hermanus one, and that's 30 meters at the back, and coastal sediments coming down to nearly the present coastline. In the case of Arniston, also that plus 6 to 8 meter wave cut. It was just fascinating to find these Holocene raised beaches. This is an excellent example. We're sitting here between Pearly Beach and Franskral. This is a level of probably plus 2 or 3 meters of these boulders, and they've been from the islands, Dyer Island, etc., where it's jointed and broken up TMS that just get rolled and weathered by the wave action and storms. So we're looking at a Holocene high stand. So we're right here at the last blip above our current sea level before there was a slight drop again. But what we were excited to find is probably similar to the Kleinbrock units that sits below this high Holocene raised beach gravels. We've got these wave cut platforms, and this is around the Varneskrans Grot. Right, we are close to just saying, yes, the Bredarsdorp group. It's not only a pretty looking rock, it can also be used for building stone, and that's the church in Stanford. And the quarry out of which these stones is a little bit in a not well maintained state. But if you look at surfaces and you look at the comparison between the actual building stone and the rock face in the quarry, one and the same. These are examples from Mosaic. And then there's also some commercial value in the Bredarsdorp, and this is an example of the lime works outside Bredarsdorp. There is a mine working equipment. You can get an appreciation for scale. That's in the order of 20-30 meters. So that's fertilized lime, calcrete for water purification, and then agricultural lime and metallurgic flux, where it's well cemented, and it's in the order of 80 plus 95% calcium carbonate. Karsrivier next to it is another mine, and this is just an example on the left from Riversdale. Right, that's pretty much the end of my talk, and that's a family of mine standing in the Varneskrans, my partner's son and boy, but at the right light setting in that cave, and you look up into it's a photo of that slab. You see the soles of ripple marks on the dip faucets in the cave. And right, thank you. That's where I'm at. Maybe just we'll come back to this a little later. That's possible excursions for next year. My last slide in my presentation is material for further reading, which you should also have in there. Right, guys, time for questions. I believe I'm just within the hour, so over to yourself, John and Annie.
Thanks, John. That was wonderful, and apologies for interfering in the middle. Just needed to, get you to think about numbers. Some of us don't sort of work with the terminology that you use day by day. But fantastic, and man, we have some amazing geology along our coastline. So we want to open it up to discussions, questions and answers, and we look forward to some good questions. Yeah, who wants to kick off? And maybe Jean, I mean, we've seen all your great slides, and this will be, it's been recorded. It'll be available on YouTube. Do you want to unshare your screen so we can see you?
Stop share. There you are.
There we go. Okay.
You've got me. Yes, the last on that screen was John. Just what the two of us were thinking about doing a field trip or field trips for the Ox, early next year or second quarter. Anyway.
Yeah, no, absolutely. I mean, you know the area backwards, and as you've just shown us, there's some amazing exposure, Jean. And I see we had other important people from the West Coast on this talk as well. And we really want to also get up to the West Coast, because I guess there's, some equally wonderful geology there, particularly, importantly, obviously, is the fossil park. So Duncan Miller, I see, is still on here. We've been remiss in not following up with you, Duncan, but it's definitely on the list for next year. Okay, and the critical and fascinating point for me, Jean, when you look at all the, and I mean this constructively, all the hysteria going on around the world, mostly from politicians, of climate change and sea level rising, and the money, the money that's been thrown at it. Here's a wonderful example on our doorstep, preserved in 3D, of the sea level rises and changes, and how quickly they can happen as well. And this, in my view, should be a training ground, or a really important area to make sure all these politicians actually come and visit it. And see what's happened. And, we're talking almost a blimp in geological time. You talk about 3 million years and less, and it's beautifully preserved.
John, for sure. And we were at those that were part of Hayley's presentation, as well as our field visit, could remember that she was telling us about the very precise cyclicity of sea level rise, ice caps forming and sucking ice up, and then the melting phase. And those were like 100,000 year cycles. And we just now saw with the Kleinbrak and Varneskrans a good example of that last 100,000 low stand. And as the sea transgressed, moved up again, and then that Holocene plus 3 meters, and then a slight drop in sea, and now slowly encroaching with a bit of rushed input, maybe from our side on the carbon anyway.
Yeah, and John, I think the other point you might want to describe too, I mean, I finally understand it, and I guess, making ice is a good analogy in your fridge. Is when things warm up, or the climate warms up, obviously things melt very quickly. So sea level rise can be quite sharp and steep. Whereas, when you go into the glacial periods, you need much more energy effectively to freeze water. So it'll take longer to drop sea level, but sea level rise can actually can happen quickly.
Sure, John. As Hayley put it, that happens in the order of tenths of thousands, the rise, whereas as the pullback regression needs maybe 100 or so thousand for that phase. Yep.
Fascinating.
Yeah.
Okay. And we can also recommend, and I see some of the people on the talk here were with us a couple of weeks ago when we had that wonderful trip to the Kelders on a gorgeous day. It really is a wonderful place to go and visit, not just, aside from the anthropology and the geology and the sea level effects. It's just lovely scenery, and it's a really spectacular part of Walker Bay. So if ever you get the chance or in the area, you'd be remiss not to go and visit the site.
Right, I've got the south coast up again, John. So that's pretty much, if you can see it, I've got my arrow. So that's the Kelders.
Yeah.
Just coming back to what we might be up to next year is excursion 1 that stops E1 to E10, and that's the stops in blue. That would focus on the coastal sediments, the Bredarsdorp group. And then there's another trip excursion that pretty much focuses on the Overberg geology. And that's the excursion 2, which we would look at more the Cape units, granites at Hagelkraal, some Malmesbury out in the Elam, some Jurassic on the way to Struisbaai, again, lovely Table Mountain outcrops at Cape Agulhas, etc.
Yeah, no, that's a done deal. And Urban, are you still on the talk? Are you going to come and join us and be one of the guides? And have you done any sampling along this part of the coastline with your big vessels?
I haven't, no, not at all. But thank you very much for the talk, Jean. I literally grew up along that coastline and with those rocks, so it's a wonderful talk. If I can perhaps just quickly ask a question, that you spoke a little bit about that the wave cut platform, and I mean when you drive from Van Huyskraans up to Bredarsdorp, you actually go across it. It obviously has a slight tilt to it. Did you ever measure that tilt? And is that tilt part of the way it formed, or did the landscape tilt slightly after the wave cut platform was put in place?
I mean, I've got that sea level curve indicating events and high stands. What I didn't point out, and I have got it there, I refer it to the BR plain, the Bredarsdorp plain, the Nieuwejaars and those areas. And you're absolutely right. It is it's so dramatic when you drive through Bredarsdorp on your way to Arniston, and then whoops, the countryside just drops away from you, and there's that coastal plain. The slope on that is indeed, there is a slope because rivers work their way seawards. That's a fact. It's a low slope. It's in the order of single-digit degrees. What is stunning is once you again at the Whoop Vlei, the eastern bank of the Whoop stands there in its full 10-20 meters, and Soutrivier worked its way across that the Whoop plain again to Nieuwejaars and Sutton, all those rivers and vleis. We struggle to see any much material preserved on that coastal plain. There's a couple of underneath the sands and the soils, you would find Bokkeveld, and you would find the outcrop of the upper Table Mountain, that's the Rietvlei. Okay, the Bokkeveld being soft in erosion also assisted that plain being just chopped in and carved in up to the foothills of the Bredarsdorp Mountains.
Okay. Yeah, and then the other thing that I've noticed, Jean, just if you look at this area on Google Earth, it's also fairly telling. I think the agriculture, the guys plant stuff on the Bokkeveld, but they don't plant stuff on top of the Bredarsdorp group. It seems to be a rough correlation between where the people farm and where they don't farm. I don't know if you've picked that up.
Urban, I mean, in the early days, in the late 80s, mid 80s, early 80s, when we did our field mapping for the survey, it was all on air photos and ortho photos. But the distinction in the fynbos species and then the Renosterveld and those, it definitely was a big guide for myself. I got in touch with botany from UCT, and we had a couple of good together field trips and visits. Now I'm talking about the 80, 85, early days for us to understand what it is. And nowadays it's specialized fields and terroirs and all those things which people get answers from. Yes.
Yeah, Evan, I mean, it's a very significant statement you make, and it's, I guess, if you look across the Western Cape, particularly the southwest down here, I mean, agriculture is almost, and I'm generalizing a bit, and maybe John Blaine wants to comment. I mean, it's almost exclusively on the Bockerfell. You know, those clay-rich deposits, they're great for holding water and holding nutrients. You know, there are some wines produced on the granites, and you know, we're not saying that the other geology is not utilized, but it's a very important point, and it should be a critical point of our, you know, land planning or town planning for the future.
Yeah, John, that's very clearly obvious, but I mean, it also is a physical thing. It's very hard to plow over quartzites and things. They tend to be very rocky. And the granites, of course, they're also extremely deeply weathered. So they produce a mixed sandy, clayey soil profile, which is certainly great for growing some vines in, that's for sure. I don't think there's too many areas that are plowed. Maybe along the west coast, there might be areas of granite that are plowed for wheat and so on. But certainly here in the Overberg, it's all vines. That's I've noticed anyway.
Other comments, questions? Steve Haggerty, are you still with us from Miami? You want to chip in? So we'll show you some of this when you come and visit in January.
Thanks, John. Oh, that was an absolutely fantastic talk. Also, living in Miami, the sea level fluctuations are almost a sufficient incentive to move back to Massachusetts. Okay. But so I found it was really wonderful. Thanks a lot, Gene. But I was really fascinated by the organ pipes and the rhizoliths. I think your idea and perhaps speculation of reed roots is not totally unfounded or lost. So really great talk. So thanks very much. But sea level fluctuations, fast and furious, are really quite frightening.
No. I mean, thanks for that one. When you look at the individual spikes or tubes, and they are where they're broken or a sharp cut through it, I struggle to really see if it's a proper reed where you can see a softer interior and and little rings, so to say, in them. So the answer lies in the field, as always with geology. And then, as you know, between geologists, we often get more than one answer to what there is. And right. Just thank you for that, Stephen, and all the way from Miami. But I saw quite a few of my old colleagues also in the back. DeVille, thanks there. DeVille was part of helping me understand the Bredarsdorp, east of Stilbay. And then a couple of guys with me from the oil patch, Andre and Andrew, etc. Yes.
Michael, have you got any comments to add to Jean's stuff, given all the fossils and weathered surfaces you've seen as well? You there or sleeping?
John, I've walked extensively along here, and just to add to what Stephen was saying there, those organ pipes are way too organized for a reed mats or what have you. I've got one right here at the moment with me, and I was looking at it yesterday. There is no, as John says, if you cut it through with a diamond blade, you cannot see a reed that formed this originally. I still go along the way of thinking that these are ripple formations in some way or another. Jean, I just wanted to ask, and sorry, this is not really sedimentology, but the emplacement of that Enon underneath the Vanco along the Sout River, just given the time that you say it's Devonian, what would be the emplacement scenario for that Enon?
If on the map, as we've mapped it, there is the contact of the Bredarsdorp is on top of, to the south, that's the Utenay, that's the Enon, that's a Jurassic. So again, that's a 115 million or so. And then in the Rurns, and that's asphalt crowns, sits on top of eroded Bokkerveld, and that's Devonian. So there we're in the, what's it, 400, 380 million range, so to say. The Jurassic unit, or it's a small inlier of the offshore Bredarsdorp Jurassic Cretaceous basin that was exploited and explored for oil and gas. So we at a very fortunate location there. You've been there 2 weeks ago again, when you visited the WIP on a walk, and we're just at that position where that west-east fault has downfaulted the Devonian to form a graben, a smallish graben that was filled in by the Jurassic, and in that case the lower, the Enon conglomerates. And then later on, millenniums later, we've got that planed events across the Bredarsdorp, etc.
Okay, no, that's cool. Thanks, John. I forgot about that graben effect there.
Thanks, Michael. Mike DeWitt, have you got anything to add before we start wrapping up?
Morning, John.
How's Michael?
Yeah, no, not really, but it's interesting that on Claymont as well, we have this beautiful wave cut platform at the back and gets onto the golf course actually. So that's another nice example of the extension of that Betty's Bay one that he showed a photograph of.
And Steve, just for interest, how high are you currently above sea level where you reside in Miami? Has he dropped out?
I'm here, about 110 feet.
Really? Okay.
In fact, the highest point in South Florida is the dump, and so that's about 40 feet high. So yeah, it's not. In fact, parts of North Miami with full moon, and then these ghost-like waves. There's extensive flooding. I mean, on a regular basis. So we're just we're in snorkel stage. Okay. Yeah.
So you and Tanya have got your canoes parked in the backyard, have you?
Not quite, but that's a good idea. Now, amphibious vehicles would be great and needed, and they'd sell like hotcakes. Yeah, if that was, it's over forthcoming.
Yeah. Okay, thanks everyone. That was excellent. Henny, have you got any housekeeping? Are you still there, Henny? Or was load shedding dropped you?
John, perhaps just the last question there to John.
John,
are any of these rocks very well cemented, or are they all can be classified as soft rocks?
Because the younger units is semi-consolidated to soft. The older units is pretty much consolidated. However, we've been into the lime quarries around Bredarsdorp, and once they get underneath that protective cap of calcrete, you're just surprised to see how soft that plus a million-old unit can also be. So yeah, but that's, I think, in general answer. Quick back to you there.
But so John, just so these, let's say that church, for example, I want to go and have a look at it. So that is built from, let's say, from these sediments, from these, let's say, cemented sediments.
Yes, I mean, a good example is actually, yes, the church, the NG Kerk in Stanford. And credit to DeVille, we were able, Mike and myself were able to trace back that quarry again. And you saw it on one slide. and there it's a proper building block. Out at Cape Agulhas, before they did the latest restoration on the Agulhas lighthouse, that lighthouse is built of Bredarsdorp. I would have, as I saw it 30 years or so ago, of the softer unit, and clearly it was weathering away, and it was in a way falling apart, and that's why they had to cement it up, and it's now covered at the outside. I would be keen to know what's still available on the inside, and if we see the Bredarsdorp's building stones that comes from within the vicinity for the Agulhas lighthouse, and coming back to get definitely a softer than the Stanford version.
Okay, thank you, John.
Okay, thanks, Sean. Thanks, everyone. Henny, over to you.
Yeah, I just want to remind everybody, next week, Mike Watkins takes on Atlantis. Myth, legend, fact, or fake paleo news. See you all at 11 with Eskom's permission next week. Thank you very much, everybody.
Thanks, everybody.
Everyone. Thanks, Sean. And enjoy the rest of your day.
Just everyone, bye for now.
Okay.
Thank
Sean.
you.
Bye-bye.
Bye.
Bye all.